Hello, everybody. In this video, we're going to discuss one new topic, which is the pipe networks. Uh, Pipe networks are a type of pipe flow that is similar to what we mentioned before in this chapter, but it's more complicated. It's more complicated because for all the cases that we discussed before, we had flow going from one point to another point. So the flow has only one path to go through. While in the pipe networks, which by the way is more common than normal single pipe flow, the pipe or the flow is going from one point and spread or distributed to different points, or it's coming from different points and it's draining in one point. So there are many examples of this, and one example is the irrigation systems. For any irrigation system, whether it's by dropping or by spraying, you will have one source, and this source is distributing water to different points. And the flow is as you see here, it has only one source and many different destination points. So we cannot deal with this the same way we dealt before. At homes, for the water piping system, we have water that goes into different parts of the same apartment, and you can extend it to different apartments in the same building. So it goes to the bathroom, goes to the kitchen, goes to different places. And so the flow is not as we used to do before. We cannot deal with it the same way we dealt before with normal pipes. The third example, of course, there are many examples. I'm just giving some few examples to clarify the point. In chemical plants, you will find there are like networks of pipes, and there are like this pipe. It has branch here, a branch there, and it's distributing the flow to different parts, and it's very complicated. So it's very common to have this kind of pipe networks, and the pipe networks, when it comes to the calculations, are much more complicated than regular pipe systems. And of course, as you have more branches and more details in the network, it gets more complicated. But we will discuss in this video why we have more complex calculations in case of pipe networks than the regular piping systems. But before we go through these details, I want to just clarify how we deal with pipe networks. So there are some basics, and instead of just mentioning the rules, I want to make it clear how we deal with this. So to make it easy for us to understand it, I like to give an example with a system that most people are familiar with, which are basics of electric circuits. I think most of the audiences have taken courses of electric circuits before in high school or in the first or second year in college. So I think this would be something that you can relate to very easily. So we know that if we have 2 points where current is flowing from point 1 to point 2, and the two resistances are connected in parallel, as what we see here, then the current will split with two different values through branch 1 and branch 2, or the resistance R1 and R2, and then the flow will go to the other side. In this case, the potential difference between the 2 points is the same, and the current will vary or will split between these two branches, so that the potential difference is equal for both points, for V1 and V2, or for two branches. So the current here depends on the resistance, and the current here depends on the resistance. So the potential difference is equal for the two branches, but the current, the total current, is the summation of the two currents here. The opposite is if we have series connections. So the total current is the same, but the total potential difference is the sum of the potential difference on R1 and on R2. So this is simply the basic idea that we need to understand. So for pipe networks, we will have the same thing, but we it's almost exactly the same, but we have to just know what is the similar between these two cases. So for these two cases, the similarity is the pressure is equivalent to the voltage. So the potential difference is equal to the pressure drop, and the current is equivalent to the volumetric flow rate, and the resistance is equivalent to the head losses. Okay, so these are the things. So if we apply these similarities between these two cases, you would see here that a pipe that's branched into two branches is equal to two resistances in parallel. So the volumetric flow rate 1 plus volumetric flow rate 2 is the volumetric flow rate. So this node is splitting the flow to two different branches with different flow rates, and again the flow rates depend on the losses, which is the same as the resistances here. So V1 plus V2 is the total volumetric flow rate, but the pressure difference is equal. And here if they are two resistances in series, so it's like two pipes in series, they will have different resistances, either because they have different diameters, or they are made of different materials, or whatever. The two main things that might be the reasons. So the total potential difference is or pressure drop is equal to the pressure drop at 1 plus the pressure drop at 2, and the volumetric flow rate is the same for the two pipes. So these are the basics that we have. So for the case that we are going to, or the calculations of the pipe networks, we base our calculations on this, that if any node, if we have any node like this, then the volumetric flow rate out is equal to N. Of course, this is based on the steady state assumption. So the volumetric flow rate is equal, and here the N equals out, and here the volumetric flow rate is the same for the two tubes, and the losses for different pipes are different based on the volumetric flow rate to maintain the pressure drop equal in the two branches. So when you put all these equations together, so this is what I just said. If you put these equations together, you would see that none of them can be solved by itself for a separate branch, and all the equations have to be solved simultaneously. So you'll have a set of equations that will be solved together to get the outlet, or to calculate the flow rates and the losses in each one of the branches, which is like a long process. It's very hard to do manually, so it has to be done using a computer software. So this is something you will do inshallah in a coming video. But my goal of this video is just to clarify the basics of pipe network analysis and calculations, and inshallah when I solve this problem, this will make things clear inshallah. So I'll see you then inshallah. Goodbye.